It's an interesting look at folding in terms of the relationship between volume, area, and as well as a little bit of algebra. I'm going to start with a rectangular sheet of paper. To do this, I'm probably going to need 2 or 3 sheets. I have some more down below me. I'm going to start by simply making a simple box. The directions for this can be found in various places, and there are many kinds of boxes. I'm just going to do one particular style. I'm folding paper in half. I'm doing it lengthwise. I mean, I guess they'd call this a hamburger fold. I'm going to do it again, taking it long and skinny. Now, once I folded this, I'm now going to make an X on either end. I'm going to fold down this corner. I'm going to unfold that. I'm going to fold the other part of the X. Got it? The same thing on the other side. Got X's on both sides. Now, the next one I'm going to do was, I'm going to unfold this halfway, so I now have 4 X's. See it? And I'm going to fold in so I can see the edge of the X. See what I'm doing there? Right on the edge of the X. Unfold that, turn to the other side. Same thing, lifting up. There are the 2 points of the X's. Increasing that. Okay, got this. Going to fold down the 2 corners. Now, what do I do here? I fold the 4 corners in. I fold this on top. And I've made a little pocket. I'm going to lift this pocket up, sort of strengthen the creases, so it's sort of like you can sort of see it's sort of a box. Now I'm going to close it by taking this part, lifting it up, and sticking out the wings. See the wings? Stick out. Now each of the wings can be now tucked into this part right here, and this part right here. If you're confused by that folding sequence, you can always slow it down and repeat, and you're going to see it again in a minute. So I've made my box. Now we're going to do a little bit of math here. I did this out of an 8.5 by 11 sheet of paper. 8.5 by 11. And I'm going to convert these to centimeters. This is like 21.75 centimeters. This over here is 27.5 centimeters, approximately. So my question is, what is the volume of this box? Well, we can measure this to get some approximations. Looks like it's about 7 centimeters tall. The base is also about 7 centimeters. So my third measurement here is a little longer than 7 centimeters, about 8.75. Okay, so it's almost a cube. Now, those are the measurements I got. I could find the volume. I'm putting up a calculator over here. So the volume of this particular box was 428.75 centimeters cubed, approximately. I should probably just say 429 for approximate purposes. Now, My question is, could I have predicted or told you the volume of the box before I started folding? That's my first question. Before I answer that question, I'm going to redo the box with the same piece of paper, but it will end up with different dimensions. So, back to the same box, putting all this stuff aside. Now, before I started by folding in half like a hamburger. Now I'm going to do the fold in half like a hot dog. So it's going to be long and slender. Going to repeat the process. Fold in half again. What did I do next? I made an X on the end. Folded that down. Unfold it. Hold this in. So I get the X. Move to the other side. Fold. Now, I'm going to do something here, just sort of a way to make this a little easier. Fold it in, make the second X. I'm now going to fold this whole triangle in so I have that crease I need later on. See that now I've got the X in a box. Other side, I'm going to do the same thing, fold the triangle in. That way I can fold against something. So I have an X sort of in a box. Unfold it. Creases at the top up here. Fold that triangle in. Triangle in. Fold the top triangle only down. So this triangle you can still see. Top triangle down. This triangle you can still see. Pull this whole thing on top. Press it flat. Going to lift the center and sort of sharpen the creases. Very box-like. Need to close the box. I'm going to lift this up and again pull the corners out to make wings and then tuck this inside. Now I made another box out of the same sheet of paper using very basically the same directions. The question is, are the volumes of the two boxes the same? So that's what we're going to approach here. Again, I'm doing it mechanically, not with any math yet, not with any algebra yet, just measurement, which is really important. I measure the base of this. I get about, let's try that again. Maybe, we'll go with about 17 centimeters. Measure the height. Not quite 5.5. This is a little less than 17. A little more than 17. So we'll go with 5.5. And then the last measurement is over here. And that's also about 5.5. Now, do we expect these two measurements to always be the same? If we think about it, this is a square side, and these two measurements, so there should be a similarity there, about 5.5, 5.5. So I'm going to grab my calculator here. And I'm going to do that 17 times 5. 5.5 times 5.5. And I get 514.25 centimeters cubed. So this one seems to be slightly larger than that one. Now that could just be measurement error, but doesn't look like it. So the question we want to move to next is, could we have predicted the sizes to begin with? So I'm going to go back to the original fold. Now we're entering the world of algebra. Let's pretend we don't know the sizes of this. This is going to be, we're going to call this length over here A, and this length over here B. Okay? I fold this in half. So now this is half of A. Fold it in half again. So this is A over 4. Whole length was A, correct? A over 4, A over 4, a fourth of A. I'm going to fold this down. Unfold it. Fold this down. I'm making my X. You can do that extra fold here where I make a nice, good, clean line. Now, when I do this, I'm making a square. So this is A over 4. So this also must be A over 4 and A over 4. So we can now see that those two measurements are always going to be the same. And none of these measurements have anything to do with B so far. So this is A over 4. And this is also A over 4. And unfold this. We know this length here is A over 4. We know this length over here is A over 4. We know this whole length was B. So this length in the middle here is going to be B, take away these two pieces, minus A over 2. Okay, let's keep folding, keep track of those numbers. We may have to move them around so we can see them. What were the directions next? We folded these two things down. It's not going to help us very much because now we've lost our A's over 4, so I'm going to write them down again. A over 4. A over 4. Folded these two in. What was the directions next? I fold this, got those in, those two are showing. Fold this on top. And when I fold that on top, I'm going to go ahead and write it down. What was this? B minus A over 2. Because I took 2/4 on either end. Now lift and straighten. Straighten the creases. What do I do next? I lift that front part up and make the wings. And I'm going to tuck those wings in there. See them? So I know that's B over, and these lengths over here are A over 4, A over 4, and A over 4. So now we actually have a formula. However, we notice the formula works exactly the same for this as it does for this. We simply have to remember that A is the side we divide, and B is the other side. The dimensions will always end up being the same. We have the A's over 4's and the B minus 2A. So in fact, I could go back to my original measurements, which were this and this, and I could compute the two volumes just from that. If I treat this as A, then I'm getting this one. If I treat this as A, I'm getting this one. So in both cases, I'm going to get different volumes, but more importantly, I can now make a general formula which can allow me to determine the volume of the box before I even begin folding.